Some numbers, they look totally normal on the outside, but underneath, they're hiding these incredible, almost magical patterns. And today, we're going to pull back the curtain and take a look at those secrets. So, let's dive right in.
All right, let's start with this one. 142857. I mean, at first glance, it doesn't look like anything special, right? Just a bunch of digits strung together. But what if I told you it's hiding something amazing? So, check this out. What happens when we start multiplying it? Watch closely. Okay, times 1, no surprise, it's just itself. But times 2? Whoa, look at that. You get 285714. It's the exact same digits, they've just rotated. And it doesn't stop there. Multiply it by 3, by 4, 5, all the way up to 6, and the digits just keep spinning around in this perfect endless loop. How cool is that? Okay, and then we've got this number, 1729. Now, if the last one looked ordinary, this one looks, well, even more plain, doesn't it? But trust me, this number's secret is something else entirely. It's like a master of disguise, a little imposter hiding right out in the open. So, you gotta be asking yourself, what is going on here? Are these just weird, random coincidences? Little mathematical flukes? Or are they clues pointing to some kind of deeper order? A set of hidden rules running the show behind the scenes? Well, that's exactly what we're about to find out. All right, to crack these codes, we need to start with our first big clue. And believe it or not, it all comes down to a number we've known our whole lives, the number 9. Turns out it's the key to unlocking a hidden structure in, well, our entire number system. The tool we need for this is called the digital root. Now, I know that sounds super technical, but it's actually dead simple. Think of it like boiling something down to its essence. You take any number, you add up all its digits. If you still have more than one digit, you just do it again. You keep going until you're left with just one single digit. Okay, let's try it out. We'll grab a totally random-looking number. How about 15876? So first step, we just add up the digits. 1 plus 5, that's 6. Plus 8 is 14. Plus 7 is 21. Plus 6, and we get 27. Okay, 27 isn't a single digit, so we're not done yet. We just do it again. 2 plus 7 equals 9. There it is. The digital root of 15,876 is 9. And what's wild is how many numbers, when you boil them down like this, end up at 9. Now, this isn't some magic trick. It's actually a super cool area of math called modular arithmetic. The easiest way to think about it is clock math. You know how on a clock, after you hit 12, you just start over at 1? Well, our number system kind of does the same thing, but it resets after 9. And that idea, the idea of these hidden cycles, that's the absolute key to everything. Okay, so let's hang on to that idea of hidden cycles. With that in our back pocket, let's go back to our first mystery, that endlessly looping number, 142857. So this number actually has a name. It's a cyclic number. And these guys, they don't just pop up randomly. No, they're created from a very specific process. They're born from the decimal you get when you divide the number 1 by a very special kind of prime number. And here's the secret origin story. Go ahead, grab a calculator and type in 1 divided by 7. What do you get? You get 0.142857, 142857, on and on forever. There it is. That's our number. It's the repeating part of that simple fraction. And this amazing loop happens because 7 is a prime number. And the length of that loop is exactly 6 digits, the maximum it could possibly be, which is always the prime number minus 1. And just so you don't think this is a one-hit wonder, get a load of this number. This beast is the cyclic number you get from 1 divided by 17. Yeah, that's 16 digits long. And you guessed it, if you multiply it by anything from 2 all the way up to 16, you'll see that same mind-blowing looping pattern. It's not a fluke, it's just a fundamental, beautiful property of how these primes behave. Okay, so mystery number 1 is solved. But what about our second suspect, 1729? It's not a cyclic number. Its secret is, well, it's way sneakier. This number is an imposter. It pretends to be something it isn't. 1729 belongs to this weird club of numbers called Carmichael numbers. The easiest way to describe them? They are fake primes.
See, they are actually composite numbers, which means you can factor them, but they are cleverly designed to pass a famous test that's supposed to weed out anything that isn't a prime. They're the ultimate mathematical imposters. You can really see the deception when you put it side by side with a real prime number. A true prime, by definition, can't be factored into smaller whole numbers. But a Carmichael number like our friend 1729, oh, it can be. You can see right here, it's just 7 times 13 times 19. And yet, its disguise is so good that it fools a standard primality test. So how does it pull off this incredible trick? Well, it's all about this really specific, almost perfect alignment of its factors. If you take the number itself and subtract 1, so 1728, and then you take each of its prime factors and subtract 1 from them, giving you 6, 12, and 18, you find something amazing. 6, 12, and 18 all divide perfectly into 1728. It's this bizarre mathematical harmony that lets it wear the disguise of a prime number. Okay, look, these are awesome number puzzles, right? But you might be thinking, so what? Are they just cool party tricks? And the answer is a big fat no. In fact, these weird patterns are the secret foundation for some of the most critical technology you and I use every single day. Let's talk about why this really matters. So these aren't just math games. They have huge, real-world consequences. Think about online security. Everything that keeps your information safe relies on using massive prime numbers. That means our security systems have to be brilliant enough to spot the imposters, those Carmichael numbers. And remember that clock math we talked about? That's used all the time in checksums to make sure your files don't get corrupted. Even those crazy, long cyclic numbers are super useful for generating random-looking sequences for things like computer simulations. When you boil it all down, these numbers are way more than just tricks. They're literally the bedrock of our modern digital security. Things that started out as just mathematical curiosities, little puzzles for mathematicians, have now become the actual locks and keys that protect our entire online lives. So today we cracked the case on 142857 and 1729. But the thing about math is, for every mystery you solve, you find a dozen more. Get this. The number made by writing the digit 1 19 times in a row, that number is prime. But here's the crazy part. We have no idea if there are infinitely more primes just like it. It's a completely open question. And it's a perfect reminder that no matter how deep we go, there are always more beautiful patterns out there, just waiting to be discovered.